Start. Okay, so hello, my name is Nicolas, and today we're gonna talk about how we can detect unexpected behavior into our front-end application. Today we will mostly focus on React application. But before we start, let's define what is unexpected behavior. So I believe it happens to every developer one day. So one day you've done lots of work to have your code ready for production. Maybe you have done lots of testing too. You've maybe QA teams or user testing your app. But at the end, it came to production and you have some very strange bugs. User complain about some strange behaviors and that are pretty difficult to reproduce. And I think you feel like this little dog. You reach the top of the stairs, but at the end, everything fails. So today, the talk is about detecting this kind of unexpected stuff. But first of all, let's see that we are not the only one to have those issues. For instance, this one is a bug that happened in Android 4 years ago. It was basically a security issue in Android, allowing anyone to bypass your lock screen. And it's very problematic for Android. This one is one from Apple with FaceTime. So basically, it allowed anyone to eavesdrop your communication. And same, very problematic bug for Apple. But today we want to focus on UI bugs. So let's let's see what can be a UI bug. So this one is an Airbnb example. At the beginning, I was looking for stays in Paris on the website of Airbnb. Then I changed my mind because actually I live in Paris, so I prefer going to another city. So I looked for stays in London. While I was browsing for those stays, so they had pretty nice stays, I got a bit surprised because you'll see in the video, but something strange happened. Some kind of results from nowhere. The result from Paris came from nowhere. It's pretty frustrating as a user. But you may think that we just have to retry the query and everything should be all right. It's just a UI problem. We can go away with it. But let's imagine it happened with your favorite shopping website. It's happened in your cart. When you want to pay, you see that it will be $10, for instance. You pay for $10, and at the end, when you check your bank account, you have something like $100. It was a bug in the UI, but it can be really problematic for you, even if it's limited to UI. So today we want to speak about unexpected problems, but I want to underline one specific kind of issues that is responsible for a lot of those unexpected problems. Today I want to talk about race conditions and how we could detect them earlier in our development lifecycle. But before we move on, let me introduce myself. So my name is Nicolas Dubien. I'm working in Pigment, which is a startup company that has started recently. So it started in last September. And you can find me on social media like GitHub, Dubs, and Twitter and Dubien. And you may want to check out my project, FastCheck. But let's move on to the subject of today. The subject of today is race condition. So first of all, let's take the definition of race condition from Wikipedia. So a race condition is a condition where the system's substantive behavior is dependent on the sequence or timing of other uncontrollable events. I think something which is important in this statement is basically the term sequence of uncontrollable events. And if you think a little bit about our front-end applications today, we have lots of uncontrollable events. For instance, what do you think about user inputs, API calls, and maybe some others we may think about? In order to illustrate that says, let's just consider a timeline. And a very simple timeline, we will just apply the example we've seen together with Airbnb. In the example of Airbnb we've seen at the beginning of this talk, I was initially looking for stays in Paris. So at that point in the code, the front-end application starts an API call for Paris. It got some results for Paris. Then I looked for stays in London. Another API call has been started, and there I got stays for London. But actually, it was not the case in the example I showed you, because the results from Paris were a bit delayed. I don't know why, but they were a bit delayed, and they came later. They came at this point. And this is exactly what we can call a race condition. The developer has not taken into account the fact that those tasks were not properly defined in the time and that some of them can come later on. So let's see together how we can detect those problems earlier. And in order to do that, we will consider a very simple example. We will consider an autocomplete field written in React. So for those of them that don't know exactly what is an autocomplete field, pretty simple. You type letters and you get suggestions when you type. So very simple stuff. And here is a possible implementation for such autocomplete fields. So basically, this is one implementation, very simple one. It has lots of drawbacks, but we will just have a look to the basics of this implementation. So first of all, we define a query. So the query is what the user is looking for. The query is initially set to empty string. This query will be used as the value of the input. And each time the user will update the query, each time the user types something in the input, we will update the query accordingly. This query is connected to an effect. So each time the query will be updated, we will trigger the effect. The effect has two main parts. The first part is devoted to deal with empty string. In the case of empty string, I don't want to fetch API results. I just want to set empty suggestions. This is just part of the specifications I had. And then in case we got some query, I just want to call the API. So my API is provided by /API, and it's called suggestions for. And I can get suggestion for this specific query. And as soon as I get suggestions, I will update my state of suggestions. And as I told you, I have a state for suggestions, and this state will be updating during the effect. And each time the state will be updated, I will render the component, and the component will see, we will see in this component suggestion right below into a very simple list of elements. So now that we have our component, we want to test it. The question we may ask ourselves is, how do we test those kind of components, and do we need to test those kind of components? So we will test, for the purpose of this demo, we'll just test the component. So basically, everything starts with a small keyword test, and we basically define the name of the test, so should autocomplete queries. Our test starts with some kind of definition of what are the inputs. So in our case, we want to define all the possible results. So our possible results are apple, banana, orange, and pineapple. We will then mock the API. In our case, I don't want to call directly the backend because the backend may be slow and I'm doing some unit tests. I just want to mock the implementation of the API. And something which is important is that this mocked implementation may be far away from the real implementation. Here, I just putting some dummy implementation to have something that looks like a real implementation of autocomplete, but it's not very important for this test actually. And then I define the user query to be NaN and the expected results, which is basically the set of all results filtered using my implementation and the user query. Then as soon as I define the inputs and expected outputs, I will render my autocomplete field. In this autocomplete field, I need to simulate what the user will do. So basically, I will type one letter at a time. I will put my query NaN into this autocomplete field. And at the end, I will have to check for suggestions that happen, suggestions that are displayed in my component. So basically, I'm checking in line 22 the suggestions that have been displayed. And at the end, I'm also checking that I've started 3 API calls because I want to call my API each time a new letter has been typed by the user. So everything should be all right. We have our test. So as any test, we run the test and it's okay. But actually, I'm a bit concerned about these stages because the talk is about race condition. We've done nothing about race condition up to now. So I'm really concerned about that. So let's take back our timeline of the slide explaining race condition. And let's consider what we do in our test today and put it into this timeline. So in our test, we simulate a user typing a first letter, N. So each time the user type a letter, we update the query, an API call is started. Then the user types a second letter, a second API call will start, and then the third letter has been typed by the user, and a third API call has been typed. If you remember the timeline about Airbnb, the problem we had before is that we don't know when promises will resolve. And basically, we may expect something like this one. So we got result for NA first. So we got result corresponding to banana. So we update our suggestions to banana. Then we got result for NaN, which is the final query we launched. And we update once again our results to be banana. And at the end, we received only at the end we received the first query, and the first query came back with banana, orange, and pineapple. So we update the suggestion to be banana, orange, and pineapple, which obviously does not fit with the queries that has been typed by the user. The user might feel a bit like in this case. So basically, he typed something and he got something different. And actually, it's more problematic than you think you may have thought about, because this is a real footage from Airbnb autocomplete, and you can see that everything is flickering due to this kind of issues. So if we have bad network condition in this with this kind of code, we can have very poor user experience. The question we should ask ourselves is, we've written our tests, everything should be all right, but the question is, what is missing in our test? Why does it miss those kind of bugs, which seems easy to detect and when we see the example? So in order to check what we are missing, let's consider this timeline again. And in this timeline, you can see that we basically change manually the order of our promises. We change how our promises will resolve so that we can easily detect issues. But what if we add some kind of tool that is automatically able to reorder our promises and given a random order, run our test and check if it works fine. And if it fails, give us a seed or something like that that give us the ability to replay our test. And it will be pretty cool actually to be able to replay our test, to have some kind of reordering of all those promises, have notification of something went wrong in our front-end application. So today I want to introduce you quickly and really briefly FastCheck. So FastCheck is a framework. I'm the author of this framework, so I'm working on this project. I have been working on this project for years now. It is initially a property-based testing framework, but among the features offered by FastCheck, one of them is very important for this talk. It's called the scheduler. The scheduler is able to help user reproducing and detecting race condition issues. And this is what we will talk about today. We will talk about how we can use FastCheck in order to detect race condition earlier into our development lifecycle. We'll not focus so much on property-based testing itself. I think you may understand along the talk what is property-based testing. But let's see how we can adapt our test together in order to bring property-based testing and most of us scheduling features to our test. So this is our test. This was the test we wrote before. So basically at the beginning, as before, we arranged the data. So we defined possible results, we mocked our suggestions, then we mimicked what the real user will do, and we assessed the results that are visible on the screen for the user. The first thing we will do in order to add FastCheck is to define what's called a property. In property-based testing framework, everything should be defined within properties. Properties are basically a set of generators that will be used by the property-based testing framework to generate randomly values. Given those generators, values will be generated and they will be passed to a lambda function. In our case, our generator is called a scheduler. This is the FC scheduler you can see on line 3. And then when the scheduler will be generated, FastCheck will provide us the scheduler, and it will be called S in our case in the async function we see in line 3. In property-based testing framework, properties are not executed once, they are executed multiple times in order to test multiple arrangements if any of those arrangements are coming with problems. So we use the FC assert stuff in order to execute the property. But now that we have our scheduler, let's use it. So what we want to do is to use our scheduler each time we call the mocked implementation. So what we do is just wrap all our mocked implementation within the scheduler. What it will do is just that the scheduler will be notified for all of those calls, and none of those calls will be released before the scheduler decided to release those calls. And now that we've wrapped those calls, we can ask the scheduler to release them, and we'll just ask the scheduler to release all of them one by one in the order the scheduler wants. Basically, with the last line, wait all, we ask the scheduler to release all the promises that have been scheduled, and maybe the promises that will be scheduled if one of those promises schedule another one that will be that should be awaited by this scheduler. At the end, we added like 7 lines of code in order to add property-based testing and scheduling capabilities to our code. it's not so much for just detecting something that is pretty hard to detect in production. But let's see if it works. So once again, we run our test, and this time we expect to find a failure because we know that there is a failure, and we added the property-based testing in order to do that. So the test fails, and we are pretty happy because it finds something. But let's see what is the failure, what the failure looks like. So first of all, the failure starts with the property failed after 3 tests. It means that the framework has to run 3 tests before detecting the issue. Then on second line, you may see that there is some kind of seed. The seed can be used in order to replay the failure. Indeed, whenever something fails with FastCheck, you are able to replay exactly the same failure given this seed. And then the part which is, I think, the most important in our case is the counterexample part. The counterexample part tells us what have been the generated values. In our case, if you remember well, in our property, we defined a single generator, which was the FC scheduler stuff. The FC scheduler stuff will generate a scheduler, and this is the scheduler that have been generated during the failure. Our scheduler tells us that, first of all, it received the task for a query on N. Then it received the second task for a query on NA. And at the end, it received the third task for the query NAM. But the scheduler decided to resolve promises in another order. It decided to start by the third one, then the second one, and then the first one. And given this precise order, we found an issue. And the issue is the following. We got extra results that we were not expecting during our test. So we found a bug. The scheduler knows and can tell us what was the original order of the promises. And it also tells us what is the final order that come with the issue. And we get the result with the issue. But let's go a bit further with property-based testing, because property-based testing is able to generate many kinds of data, from scheduler to very simple stuff like strings and array. So let's see if we can go deeper and test even more things into our application and detect more bugs. So first of all, what I want to do is to change the expected results. So this line in the code. Basically, the expected results today have been hard-coded to be banana, but I would prefer to have something that can be computed easily. Basically, the expected result is just a set of all results that have been filtered using the mocked implementation and the user queries that we have typed. So we can just rewrite this stuff as you can see in the slide. Then I want to ask the framework to generate a user query for me. I was pretty lucky actually in this test because I was looking for NAN, but if I was looking for something like ZZZ, for instance, nothing would have happened and no failure would have been found by this framework because all the queries would have resolved with the same result, nothing. So I want the framework to be able to generate something for me. I want the framework to generate a user query. So basically, I ask the framework to generate a string. And in my case, I want the string to have at least 1 character. So I tell the framework I want a string from 1 to 10 characters. And I take back this string as a second argument of my query, and it will be called user query. Then same thing, I want to generate a set of all possible results because once again, maybe those all results have something strange, and maybe I will cover more cases by generating something random. So basically, I ask the framework to generate a random set of strings. And this is it. We got the all result, we got the user query, everything has been randomly generated. Actually, we can go a bit further. What I told you at the beginning of this talk is that we want to mimic as much as possible the real behavior a user will have on the autocomplete. And basically, if you think about your user will type some letters, some promises may resolve, and type other letters, and some of the other promises will resolve. And actually what we did up to now is that the user is typing everything, and only when the user ended typing everything, we wait for the promises to resolve. We want to be as close as possible to the user, so we want the user to type stuff, promises resolve, type stuff again, and promises to resolve in between. So in order to do that, there is something provided by the scheduler generated by FastCheck, which is called a schedule sequence, and we can schedule what you call the sequence. A sequence is basically a sequence of dependent operations. So basically, the first operation needs to be executed and ended before running the second one, and so on and so forth. So basically, our sequence of operation will be the user typing one letter at a time. So we define a skid or sequence, which is the user will type one by one all the letters, and in between, we may put some of the backend answers. So I think we're done with this example. We've put property-based testing into action for this example. So let's see how it works now with this final implementation. So the test fails again. In this case, it failed after 3 runs. You can see the seed that you need to use in order to replay the problem. And basically, you have another thing which is pretty important in the case of FastCheck, which is called the pass. The pass will give you a way to replay only this failure and not all the failures that bring you to this issue. Actually, FastCheck is doing more than just generating a simple cases. It will generate lots of cases. And at the end, sometimes if it finds an issue, it will try to give you something that is human readable. Indeed, we ask FastCheck to generate user query. We ask FastCheck to generate a set of all results. So it might have come with a big array of results for all results. But at the end, if you see the counterexample, the final all result value for all results was only an array with a single value, which is A. Actually, FastCheck is doing what we call shrinking, and shrinker is able to reduce the failure to something smaller that is easy to understand for you human. And this is exactly what we want in this case, because race condition issues can be very complex, and we want to have something that is human readable and that can be easily debugged by someone. So let's see what we've seen up to now together. So first of all, we've seen that race conditions are real in our front-end applications. I think we can say that they are by design because everything in the front end is event-driven. So we don't know when events will occur. Maybe the user will type, maybe the user will click somewhere, maybe the bar address will change, stuff like that. We cannot control those stuffs. Then a possibility in order to detect those issues earlier is to reorder events and reorder when they come. And the last part is to use some kind of randomness in order to detect stuff that we've never thought about, stuff that computer can find by playing with random, but that we will spend years to detect. And random is already used by big companies. I know that Google is using what they call fuzzing on Chrome in order to detect bugs. And Facebook actually use random stuff on React in order to detect problems. And today, just the last thing we've seen together is FastCheck. So just for you, FastCheck is used by big project today. It's already used by Jest and Jasmine to detect issues in their code base. And it's already proved very useful on Jest, Jasmine, and React to find some bugs. And if you have more questions about property-based testing in general, race condition, and stuff like that, you can find me on social media at Dubs or Dubien if you want to.
Right. Yes. Nicolas Dubien's sequence of uncontrollable events. I like it. Yeah,
Thanks.
you know, React gives us a very rich API and does a lot of work for us, but there are always ways that you can shoot yourself in the foot and run into errors like race conditions, introduced by the developer. My question was going to be at the first, what can help us with this? And obviously, it's this library. I also think that this is a hard issue to tackle. So when I find a library like this, it's great for me as someone who doesn't know a lot about the topic to kind of dig into the library, and it shows me how to kind of work with these things. But we have a few questions coming in from the Discord chat. Let's see. The first one was from Fen. What's the compatibility with TypeScript for FastCheck? Could there be automatic testing via types?
Okay, so FastCheck is written in TypeScript, so everything is TypeScript compatible, as I understood well the question. So normally you should not have any issues with TypeScript because everything is in TypeScript. And it's also work with JavaScript, purely JavaScript.
Great. And I want to utilize, go ahead, Patrick.
No, it's okay.
No, you go ahead.
Okay. I wanted to make sure that we take advantage of all these great speakers being online here with us on the panel at the same time. So why don't, Patrick, you had a question that you were going back and forth with Mike in the Discord. Do you still have a question regarding that?
No, it's fine.
Okay. And then Swix, how about you?
I just noticed some superficial similarity with model-based testing, which is something that people have also been testing about. Like, it seems like property-based testing is kind of like a smaller version. I don't know if there's like a 2x2 matrix where like model-based testing is up here, and then property-based testing is faster or slower or more constrained. Any thoughts on how you compare those two?
I think there are some kind of parallel techniques to test stuff. Property-based testing will test you by using randomness, mostly on user input. You can simulate what the user can do and stuff like that. Model-based testing is a bit different. FastCheck, for instance, provide both. You can do model-based testing with FastCheck, so it provides you a way to just simulate random inputs and orchestrate the way that events are occurring in the front-end application. And at the end, it reduces everything to something smaller, which is, I think, the key capability of FastCheck today, which is you take a very complex scenario, and at the end, you get something very simple to understand for the end user. But I think both techniques are complementary. You may need to do model-based testing. You may need to do pure property-based testing, but both are handled by FastCheck today.
Awesome. Thanks.
Another question coming in from the Discord chat. Does FastCheck print random generator seed it used to generate the failing test? And does it allow passing it to the next test run to reproduce that failing test?
Yes, we can take the seed. We can get back the seed from the test, and we can use it to run another test. Most of the time, we don't use the seed that has been produced by the runner, but we can do that because it's outputted by the framework. So why not?
I have one last question, and then we'll go on. I think you were able to find a bug in React.js itself.
Yeah.
To tell us a bit about it. That's pretty cool.
So the bug in React was about suspense. So basically, the problem was a race condition. So basically, when I started the part on race condition, I said, okay, that's pretty nice. It works with an autocomplete. So let's see if we can do something a bit more interesting. Let's work with React and check how they did their test. And the bug is just when you play with suspense and you have some promises and you change the promises in between. So this is the next implementation, the next stuff for suspense. You had something that never rendered properly at the end. So you get something very strange that is never rendered in the front. But the issue is still pending for the moment. So it's a real bug, but the issue is still pending up to now.
Cool.
Great. Amazing talking. Can we just confirm that we had a question? Were you using Reveal.js for your presentation?
Yes, it's Reveal.js for the presentation.
Perfect. Thank you. And we'll hand it over to John to introduce the next speaker.